In this video, I'm going to look at a defective Class D amplifier. Now, this is a brand new module that was DOA out of the box, and we have some really nasty distortion. So let's put it up on the scope and we'll do some tests on this thing. Just take a look at how bad this is, and I'm being sent another replacement to actually do a review on. So let's just do a quick review of this bad one and see how they're not supposed to work. So on this board here, this is another 100 watt. This is a mono Class D amplifier board. So this one will accept a balanced input on the headers here. It's got a ground pin. It's got your positive and negative input, which is, if you're hooking it up to a balanced source, you'd have your positive and negative balanced input. It has a mute pin that will ground or will mute the sound, and it has your speaker terminal here and your voltage source, which is 12 to 24 volts. I'm feeding it with 24 volts. And we're going to take a look at this one's performance and look at it on the scope. So I've just got my music source here. Got my DAT machine. I will hook up the ground pin to ground over here. I'm just going to bend that pin over a bit. Because I'm using an unbalanced source, it doesn't matter whether I go with the positive or the negative pin. They'll both give me an input. And I've got my scope here. We'll take a look at the signal. So let's power this one up. We've got power. Now the first thing I noticed on this unit here, if I look at the scope, and maybe it's just this board, maybe this is a defective board, but if I look at the RF coming off of the switching driver and we scale it up to take a look, I'm seeing, even with no input, I'm seeing my nice 50-50 waveform here. But take a look what happens, and I'll move this over so you guys can see what I'm testing. I'm testing here on the high side of the inductor. When I go to the speaker side, I shouldn't see anything, but I am. I'm seeing some leakage through the low pass filter that's making it to the speakers, and there's actually quite a bit of leakage here. It looks to be about 6 volts of leakage. So I don't know whether this is just a bad. I'm going to say this particular sample they sent me is probably bad. Here's our peak to peak. If I can get the scope in here again. If we look at our switched output here, okay, 23.6 volts, 28 volts. It shouldn't be that high. Yeah, 23.6 volts. Anyway, I'm only giving it 24 volts, but we get our amplitude 27 volts. Looks like now, if I hit my measure button here again. .6 volts. If I go to the speaker terminals here, I'm seeing an amplitude of 5.94 volts. If we go back to the inductor, okay, this one's operating at 120 kilohertz. See our frequency there, 119.9. It's hard to get in here with the scope. Unfortunately, it's really quite a tight fit to get in here and touch these pins. And if I go to the other side of the filter, you see there, it's leaking through. We got like some 30 kilohertz leakage getting through here, which is making it to the speakers, which is not really good. We shouldn't have anything, even with no input connected to this thing. We've still got some leakage. If I turn down my time bass, let's play some music and see if this thing produces any sound. So as you can see, here's our music. It doesn't sound really good either. It sounds kind of raspy. Doesn't sound very good at all. I would have to say that this module is no good. Just by comparison, let's hook the same source up to this little module. This is the 50 watt per channel, and I'll feed it with, that's even getting warm. This IC is getting, I think this module is defective, you know, right out of the box. But let's just hook this other one up and we'll take a look at this other one here again. So there's, I'm gonna hook up both speakers on this. So there's, where's my speaker output on here? Right speaker, positive and negative. Here we go. And I'll just take my other speaker off of my other little amp board that I'm really happy with. What I'm gonna do with this Bluetooth one, which you'll see on in a future project, is I'm actually going to build this inside. I'm going to pick up some nice bookshelf speakers, like some nice sounding bookshelf speakers. I'm going to put this inside the speaker cabinet itself and use the binding posts on the speaker as a jumper from one speaker to the other. Then I have a wireless speaker, good sounding wireless speaker with this inside it. I think that's going to be my project. You guys will see that coming up here pretty quick. Hook up the other speaker here. I'm going to give this one 24 volts as well. The last time I tested this, I was testing it with 12 volts. So we'll give this one 24 volts. Plug this back into my sound source and we'll give this thing power. And we'll see how this one sounds. First of all, we'll clip on here and make sure that we don't see any signal leaking through on the outputs, which we don't. Okay, this is how it's supposed to be. There's no leakage here, no RF or leaking through, and just the music. As you can see, those distort quite a bit. I think if you listen to this one here, this one's got it's a brighter sound than the other unit for sure. I think this one here, I think this one has a better sound, even on these little crappy speakers. But this is this one again. We'll look at our RF on this one. Yeah, so I believe this little board has got a problem. Let's take this heatsink off and take a look at this thing. Now I want to give this other unit the benefit of the doubt before I condemn it as being defective. The specs say it operates on 12 to 24 volts, but I'm going to give it a try on 12 volts. I was running it on 24 before, so I've taken one of the power supplies off going to run it on 12 volts now and just see how it sounds on 12. So here's our waveform coming off of the actual PWM driver. As you can see, it's nice and clean here. We'll look at the secondary side here. Now this is where I was getting all, so I'm still getting some ripple leak through here. So that's still going to be, I'm sure, going to make this thing sound pretty raspy. Oh, that would explain it. Not connected. Hear how bad it sounds? It almost sounds like my speaker's blown. I don't think my speaker's blown. We'll try the other speaker on there. This amp definitely has a problem. We'll try the other. I mean, it sounds like a blown speaker, but my speakers are fine. I just had them hooked up to the other amplifier, and it didn't sound like that. We'll try the other speaker here and see if it sounds all distorted as well. Yeah, it does. Listen. So this unit is no good. This is a defective unit out of the box. So what do we do with things that are defective out of the box? We take them apart. Let's take a look at what's underneath this heatsink here. Sometimes we do that when they're not defective too, right? There's our IC. I'm just going to take a close look at this and see if there's anything that I can see that might be causing all this distortion, but it's probably the IC itself is bad. Let's take a closer look at it. So here's the unit with the heatsink off. As you can see, it's a very, very, very simple circuit. It's basically a single chip design. You've got your low pass filter here. You've got the two inductors with the capacitor and resistor network here to filter out the high frequency sound from or high frequency noise from the switching IC, but yet that high frequency noise is still making it to the speakers. So we have a problem. Either it could even be the design of this thing, but I think probably one of the components isn't working properly. So when I put power to it with the heatsink off so that we can actually look at the signals a little easier here, you see all this noise. These noise spikes here, even when it's under a no signal condition. And those are going to be coming right out of the IC itself. Unless they're getting into the input. This thing should normally mute itself when there's no input. Like that, when I put my finger on it. I guess what I'm doing is I'm bridging the or putting power to the mute input here when I touch it. You can see the level here leaking through. We have an excessive amount of leakage leaking through to the speakers, which is unacceptable. I mean, we've got about 5 volts, right? We got about 5 volts of power leaking through. Okay, it says 2.93 volts. I'm on the 1 volt, so 1, 2, yeah, 2.9 volts at 117 kilohertz is leaking through to the speakers through this network. So I have to say this, it's probably not, it's probably a design problem on this. It could be a bad component, but I bet you it's just a bad design. We shouldn't have anything leaking through to the speakers when there's no signal present. Yet we do. Now 117 kilohertz you're not going to hear right? It's well beyond the hearing range, and it's well beyond the range of your speakers, but still, that's going to, that signal that's getting there is going to get to the tweeters, and that could cause damage with something like this. It's not working properly. No heat. It's not like it's getting hot or anything, but certainly it's not working properly, and it sounds like crap. Let's put my tone generator on it and see what it does. Now that's not good for your speakers. $10 Hz? Anybody? $10 Hz? Thing's not even getting warm. Distortion. Oh, wonderful sound. Listen to that distortion. $10 kHz. Beauty, huh? Listen to it. I don't know if you guys can hear the beating, but it's pretty ugly. The beating sound between the 10 kHz signal coming. Look at how ugly this thing looks. Oh, what a mess that signal is. That should be a nice clean 10 kHz signal, but no, not on this thing. This thing is just a mess, this amplifier. And we look at the switching signal here. Look at all the noise on this. Actually, it's not too bad there, but if we look at the output here, I mean, part of the reason this thing looks so bad is because of all that noise that is mixing in along with the sound. That's just from the chip itself, from the oscillating frequency being a low frequency like that. You can hear it as I bring the frequency down. Ooh. That's around 15 kilohertz. Let's go a little higher. 20. So now we're at around 39 kilohertz, and well, it looks like an AM waveform here. Not a joke. Let's go a little higher. Now remember, the input for this should be a nice, clean signal like that, you see? Here's my input. Okay. There's my input. My output is pretty ugly. About the 50 kilohertz, you know. We'll play with this some more. Let's bring it back down and we'll go to the next frequency band up. 60 kilohertz, 70 kilohertz, 80. Let's go up to the 100 that it operates at. Should be interesting when we get to the actual frequency that the oscillator is running at. We're injecting at about 250 kilohertz now. Now, one of the reasons this thing sounds as bad as it does is because of this leakage. This is heterodyning. This noise coming through this amplifier, this noise is beating with the tone. Let's try the other one that doesn't have all that leakage on there and see if it fares any better. So we'll just disconnect our power here. And we'll get the other little board here again. We'll just run it at 12 volts. So we'll put our tone onto this one. As you can see already, already sounding a lot better. Now remember, this generator is not perfect. I'm not loaded into a 600 ohm load, so if we remember looking at the input for the generator before, it was a little bit, the top end of the waveform is not quite smooth, because this is supposed to go into a 600 ohm load, and it's not. So, and the capacitors in this thing are probably 50 years old. I don't remember when it was calibrated last, but I think it was calibrated around 1970, so a long time ago. Let's run this one up and see how this one sounds. 5 kilohertz. Remember how noisy the other one was when I got up to like 40 kilohertz? Well, this one you're not hearing any beating. You can certainly see it here. 20 kilohertz down. Here we start to come down. We're around 14 kilohertz now. Go up to 50 kilohertz. We're not hearing any of that beating that we heard on the other one. Now, one of the reasons probably for that is because if we look at the fundamental on this, what frequency is this one operating at? Let's see here. So as you can see, this Class D, as you can see, 1.19 megahertz is the oscillator frequency on this little amplifier. And that's why we're not getting all that beating when I put a really high frequency signal. Oops. That's the signal going in. Hertz. Kilohertz. So, yeah, this one here. This one's a fail. Sounds like crap. The switching frequency is way too low. At only 110 kilohertz. This one's at a megahertz. This one. The other little MP3 one, I think, what was it, around 400 kilohertz? I think it was 400 kilohertz. It was up there. I was going to hook this one up to the audio generator to see how it sounds as well, how it performs. However, I can't do it. Because this one here, it is in a mute state until the Bluetooth receiver receives a valid signal, and it actually shuts the amplifier off. So this header up here, which I was able to look at the audio signal coming out of the Bluetooth receiver, I can't put a signal into that. Well, I can put a signal into it, but it won't do anything if the Bluetooth receiver has it muted. Bluetooth receiver only outputs a signal when it's actually processing a signal, and it shuts the power down when it mutes it when there's no sound. So that can't be used as an input without some type of modification. It's an output only, but hey, this is a Bluetooth board, so we aren't going to even consider that. We know how good this one sounds. I don't need to run tones through it. We know that this other little one here sounds really quite good on the audio generator, and this one here sounds utter garbage. That's it. That's all this video is. Catch you later.